So this video is for Unit 5, Activity 2. I've had a few questions regarding Activity 2 and Activity 3, so I'm going to make one for this question and kind of twist it around so that it helps with the other questions in this worksheet or this assignment. So we're going to start with looking at what they're looking for. So first of all, we're looking for the probability distribution. So it's important to know what a probability distribution looks like. A probability distribution is basically a fancy word for table. Okay, so it's a fancy word for a table. So you're just basically making a table where you have your random variable x, and then you have the probability of x. So I'm just going to write it this way. So random variable is your x value. Okay, and that's always x equals lowercase x. And I'll try to explain that in a minute. And then here we have the probability of that x value. Okay, so we know that we needed some type of table. Now it says for the number of girls in a family with 4 children. Now, the reason that you can't just say the probability of having a girl is 50%, so the first time would be 50%, and then the second child would be 50%, and the third child would be 50%, and then finally the last child would also be 50%, because you only have 1 out of 2 chances of getting a girl. The reason you can't just do that and multiply all values, because we're using the word and, is because you may have 0 girls, you may have 1 girl, you may have 2, you may have 3, or you may have 4. So the number of girls is your random variable. So you want to kind of define that. So random variable, okay, here, is the number of girls. So the reason I know this is if I read the question, it does say, find the probability distribution for the number of girls. So it's important to know exactly what that random variable is before you start doing this table. So if I'm going to have a family of 4, the random variable can assume different values. So how many girls can you have in a family of 4 children? Well, you can end up with 4 boys and 0 girls. So x equals 0 could be a possibility. We can have 1 girl in the family, we can have 2 girls, we can have 3 girls, and then finally we can have 4 girls. Good luck to the parents, but you can still have 4 girls. So now to figure out that probability, it's not just as easy as doing the multiplication by 0.5, as I said, because if you do, let's say 0 girls, well, 0 girls is a little bit easier because no matter what, you're going to have 4 boys in this situation. But let's go with the 1 first. I'm going to start with the 1 just so you can understand why I'm doing what I'm going to be doing. So if I use the 1, the probability of having 1 girl. So here's the thing. If you have 1 girl, they can end up with having the girl first. So if they have the girl first, that means that they have a boy and then another boy. There's another possibility. Okay, here I'm going to word these in between. I'm just going to put the word and so that you understand what operations I'm going to be doing in a second. Or you can have the girl second as the second child. So that would mean you had a boy first, you had a boy third, and you had a boy last. Or you can end up with the possibility of having that girl third. So that means you have a boy first, second, and fourth. And then finally, the girl could come last if we're doing the random variable equals 1. Okay, this is just for 1. So this is why it's not very easy to do. And when you see the word and, over here, we need to multiply. If you guys remember that, hopefully you do. If you don't, well, this is a good refresher. So the probability of getting a girl is 0.5. When I say and, I multiply by the probability of getting a boy. The word and again, multiply by 0.5, multiply by 0.5. So this is essentially what I was telling you from the start. If you do this multiplication, I actually need a calculator to do that. So I'm just going to type it out. Just want to show you what it will give you. So 0.5 to the power of 4, or 0.5 times 0.5 times 0.5 times 0.5. So it's equal to 0.625. Now here's the problem. There's 3 more situations. So if you do this it will give you the same answer. Okay, 0.625. This will give you the same answer, only because the probability of having a girl is 0.5 all the time. Okay, so the answers are the same only for that reason. Now, when I say the word or, you have to remember that the word or means to add. So now that you've multiplied all those numbers that give you 0.625, you're not quite done. You've got to add up all of those probabilities. So you see how it can take a really long time? And this is why someone discovered that there's something called a binomial distribution. And by recognizing what kind of distribution it is, it saves you all of this work. So what I'm going to do is I'm going to take this, and I'm actually going to delete it, because I want you to recognize right from the start, why is this a binomial distribution? It doesn't tell you in the problem. It doesn't tell you if it's binomial. And you'll see other types of distributions. I believe you already saw the uniform distribution, but you will be seeing different types of distributions as you move along. So it's important for you to see that when we're looking for probability, oftentimes there's some type of distribution that can make your life a lot easier. And in this case, it's binomial. So binomial distributions, if you look in the note, binomial distributions have a couple key factors, okay? It has to be a success or a failure. So you have to have either a success or failure. So you either have a girl or you don't. And the events have to be independent of each other, which means that one outcome doesn't affect the next outcome. So if I have a girl first, that doesn't affect my next outcome. I can still have a girl as a second child if I have a girl as my first child. So all of those events, when you're having a child, those events are independent. In the case where, let's say you're playing cards and you're taking a card out of the deck, if you take that card and you replace the card, you put it back in the deck, that means that will affect, if you put it back in the deck, it won't affect anything. But if you take that card and you leave it out, that means that there's one less card in the deck affecting your next choice. So it's important to know which situations are independent and which situations are dependent, because all of these kind of look the same. If you need help with that, please just let me know and I could go through a couple different examples. So in order to continue here, we now know that it's a binomial distribution because you're either going to have a girl or you're not, and the events are independent. Having a girl first will not affect having a boy or a girl in my second when I have a second child. So now that we know it's binomial, there is a formula for that. That is in your notes, and I believe it looks like this. So you have your N, you have your R, you have your probability of success, to the power of X, which is why I need to erase the R that I just drew there, and it needs to be an X. Okay, so just remember that. And then we have the probability of failure to the power of N minus X. So all of this is the probability that X equals your random variable, whichever one you're looking for. So in this case, what I'll do is I'll do the work on the side here, and then I'll go ahead and fill in my table, because I need to find the probability of 0 girls, 1 girl, 2 girls, 3 girls, and finally 4 girls. So if we start with the probability of getting 0 girls, remember that capital X represents the number of girls that you want. That's your random variable. Now N is the total number of times the trial is tried. So in this case, the total number of trials would be 4, because you're having up to 4 children, so that means 4 times. So 4 times is a total amount of times, a total amount of trials, and our X variable is equal to 0. So here we want 0 girls out of 4 children. That's what this expression means. Now P is your probability of success. Your probability of success when you're having a girl would be 0.5. Okay. Your probability of failure, which is 1 minus P, anytime you're looking for the opposite, so if you're looking for success, you find that one at 0.5. To find the other one, so to find the failure, you do 1 minus 0.5, and in this case, it's still 0.5. Or you can think of it as success is having a girl, so having a girl would be 50% chance, so 0.5, and then failure would be having a boy. In that case, having a boy would be still 50%. So there's a couple of different ways of figuring this out. It just kind of depends on which way you prefer. So my P is going to be 0.5. My lowercase x in this case is 0. My 1 minus p is 0.5. I'm going to put that in a bracket because that's going to be considered a multiplication. N minus x, so we have 4 minus 0 here. Okay, so here I'm just going to do 4 to the power of 0, 0.5 to the power of 0, and I'm just going to simplify this just to show you what this looks like. So notice here how you have a 0 for the success and a 4 for the failure. Well, these two numbers add up to the n. So if you have a number there that doesn't add up to n, you know you've done something wrong. Okay, so just be very, very careful. So in this case here, we're going to go ahead and calculate this. Not sure if I can calculate that on this calculator. So I'm just going to pull up my other calculator. Okay, so different calculators kind of act differently, but I'm just going to use my online graphing calculator. You've done combinations before, so you need to remember how to do those combinations. I type in the number 4, I find the combinations button on my calculator. Could be a second function if you remember that, and then I press 0. So the possible ways of getting 0 girls out of 4, there's only one way that can happen. So I'm just going to close that. 0.5 to the power of 0. Well, 0.5 to the power of 0 is equal to 1, so I'm just going to change these expressions to multiplications at this point since they're all stuck together. And then 0.5 to the power of 4, which we already know what that is because we calculated it earlier when I was trying to explain how this was done. 0.0625. 0.0625. So in this case, the probability of having 0 girls is 0.0625. Okay. So that's how you use the formula. But before you use that actual formula, you have to decide what kind of probability distribution it is. So for here, it's 0.0625. I'll go ahead and do the probability of getting 1 girl. Okay. Again, I know it's binomial. I don't want to go through and multiply everything and add everything. It just becomes too confusing. So I use my formula. Okay, so with the formula, it's already written at the top here. I'm just going to shrink this a bit. So I'm still having 4 children, but this time I want 1 girl. My probability of success does not change, except this time my x value is equal to 1. My failure does not change, but this time it's 4 minus 1. Okay, so 4 minus 1, which is actually equal to 3. So remember that this number and this number need to add up to the total number of trials. So when you go ahead and you type that in, you get 4, choose 1, which is 4, so it can happen 4 ways. 0.5 to the power of 1 is 0.5, and 0.5 to the power of 3 is 0.125. And in this case, we get 4 times 0.5 times 0.125 equal to 0.25. So if you want to convert this to a percentage, feel free. Okay, so 25% chance. I think that's what it was. 4 times 0.5 times 0.125. Yeah, so 0.25 is what it is for the probability of getting 1 girl. So you would just continue the same pattern, except you would change your random variables to the values 2, 3, and 4. And then I'll just give you the answers here because they're not in the actual solutions, which is really odd. So we're just going to go ahead and write those out. So 0.25 and 0. Okay, so 0.25 and 0.0625. So you notice that some of these are kind of the same, but you need to show your calculations in order to get full marks. Now, in the solutions, they do it in fractions as well. I'll do one of them in fractions, so it's not too difficult for you. So here we have x equals 0. Remembering that 4 choose 0 is equal to 1. 0.5 is 1 over 2 to the power of 0. And then another 0.5 is 1 over 2 to the power of 4. So if you keep these as fractions, you get 1 times, again, anything to the power of 0 is still 1. When you do fractions with exponents, you have to distribute the exponent to each. So 1 to the power of 4 is 1. 2 to the power of 4 is 16. Okay? And when you multiply fractions, you multiply the tops, and then you multiply the bottoms. so you can get a fractional answer as well.